Okay, today we're going to do a little quick video on series turbocharging. We've covered variable geometry earlier in the week. So the series turbocharger is two turbochargers put in series, meaning it has to go through one to get to the other. So there were some misconceptions when these came out. Everybody said that the turbos fought each other and that one got in the other's way because you have a low pressure and a high pressure. One thing I want you to keep in mind is it works backwards of what you would think. You would think that you have a low pressure turbo for low RPMs feeding a high pressure turbo. Well, actually, the high pressure turbo feeds the low pressure turbo. So just keep in mind that it works a little bit backwards. And basically, if you think of, if you got two people doing a job and one of them is really good at one area and the other one's really good at the other, you generally get a better product and a lot of times than you do if one person has to do everything because they may be a little better at one than the other. So that's kind of the whole theory behind this turbocharger thing with putting them in series. You do have a wastegate generally. So as the first turbo or the high pressure turbo kind of limits out, because remember, to get high pressure you have to have a smaller area, and that's why it's backwards of what you would think. So as the high pressure turbo, which is actually used at low speeds, because remember we need more boost and all that and not have turbo lag, as it reaches out where it would become a restriction, what we used to do was open the wastegate here, right, and allow that excess exhaust gas to flow into the exhaust manifold and not let the turbo be a restriction. What happens here is when that wastegate opens, it feeds more exhaust to the low pressure turbo, which has a lot higher, bigger area because of low pressure. So once the high pressure maxes out for your low speed, then the low pressure kicks in and starts boosting what the high pressure is put out. So you wind up with a higher turbo pressure and a better boost across the range. VGT does a good job too, but it has its limitations, so both kind of have to work together. It is common on a lot of the newer trucks to see a VGT on the high pressure and then a regular low pressure turbo, so then you wouldn't have the wastegate because you got a VGT. But anyway, most what we were saying now has a wastegate on there. So VGT maxes out about 45 psi on boost. A lot of these series turbos can do 60 or higher, so kind of 60 is the rule of thumb of what a series turbocharger puts out on boost. A few more things about it. If you use, since you don't have a VGT to control back pressure and let your EGR valve flow, because remember, the EGR valve controls how much flow you have going into the engine of exhaust gas, but back pressure or boost pressure helps with that. But just remember that the valve is who's ultimately in charge on that. So if you have series turbochargers, you can't use a high pressure EGR like VGT does. So if you're using a low pressure EGR, kind of the problem you have is you're trying to get exhaust gas to flow back into a pressurized manifold like we talked about before. With the VGT, we could increase exhaust back pressure out of the turbo and make it flow into the intake manifold because it had to go somewhere, was kind of the way that worked. With low pressure EGR, which is what you have to have for a series turbocharger, since you don't create any back pressure in the exhaust with the turbo, it actually has a throttle plate. Now remember, we talked about this. Gas engines use the throttle plate to regulate how much air goes into the engine to control speed. Diesels don't. We control how much fuel and run on excess air. Well, they put a throttle plate on a low pressure EGR engine, but its job is to restrict the air coming in and make the exhaust gas flow into the intake manifold. So if I put a little bit of a restriction here on my air coming in, but I've got an exhaust valve open, or EGR exhaust valve, exhaust gas recirculation valve open, then that's going to flow because my boost pressure is kind of restricted. My airflow is restricted here, so it's going to flow more exhaust. So just remember, series uses low pressure, VGT uses a high pressure EGR. Okay, and of course, a lot of series turbochargers use a aftercooler, so it's a charge air cooler. Aftercooler, intercooler is kind of the same thing. It's a slang term for intercooler, but intercoolers use engine coolant to cool it down, so it's kind of like a miniature heater core, but it's working backwards. So as far as absorbing heat, like we covered in AC, so you still have a lot of times your air-to-air charge air cooler out in front of the radiator, but if you have series turbochargers, you'll have a intercooler or aftercooler, which is a charge air cooler using engine coolant. Then it will go out, that gets rid of part of the heat because they do generate more heat. That gets rid of part of it, and then it will go out to an air-to-air charge air cooler where you got that 70-degree ram air coming across it to cool it down even more. So you probably have 2 charge air coolers on a series turbocharger system.